This is a presentation of Chapter 3 in CCNA1. It's the first part, and the chapter is about network protocols and communication. So the first thing we're going to have a look at is what is communication, because when we're talking about networking communication on computer networks, we can compare it to the normal way that we communicate between humans. Because in all these types of communication, we have some sort of a source and a destination, and then there is some kind of a communication between these two. If we look at it in a human perspective, we can see that if two people are talking to each other, well, then we have the one being the message source, the other the destination, and then we send our signal, for instance, as voice in which is air transmitted. So the air with the sound waves are the transmission medium. And the same thing will more or less apply to communication over a network, a computer network. There are some things we need to agree upon before we start communicating. For instance, could there be rules about when to speak? Do we take turns, or am I the only person speaking? What do we do if we don't understand what we are communicating? We need to have some kind of a reference of a language, a same common language and grammar. If I'm talking to someone who does not have Danish as a first language, I need maybe to set the speed down so that they will understand if I talk slower, for instance. And we need to make sure that if I'm telling you something, you need to acknowledge back to me that you actually understand what I'm talking about. So all these rules need to be described. And when we are talking about normal human interaction and human communication, these rules are just something we know. And of course, we have learned them from when we were children, that you will not talk while others talk and things like that. But in computers, we need to be more formalized and set these rules into a system. And the system is called a protocol. So here is an example where we have communication between two computers instead of two humans. So more or less the same thing applies. We have a source and a destination, and then we have some kind of a message that are sent, and we have some signals depending on what kind of a network that we are communicating on, and we have some sort of a transmission medium, which could be wireless, and it could also be some kind of a cable connection. But we need to have rules, and we need to find out how will my communication go from the source to the destination. What are all the rules that we need to impact on this kind of communication to make sure that everything is sent and received in the correct way? And when we do so, we put our messages into something like envelopes. It's encapsulated into something else. It is put in, the data is taken, and we put some extra information on top of that data, which could be, where do I want to send it? So it could be the source address and the destination address, typically, that we put on to our data. Like we will do when we send a letter, for instance, where we put on who's going to receive this and who sent this letter. Of course, also, when we are writing a letter, if it's a more formal letter, we also know that there are certain rules of how do we greet people. You say, hello, Mrs. blah, blah, and also that you put your name in the top of the letter and so on. All these rules that apply to a formal letter is more or less also applied into data communication, because we have certain bit patterns in the beginning, which is just an opening packet saying, okay, now something is coming, and then the data is coming after that. And we need to somehow also know when is it ending? What is the last part of this message that I'm sending? Same thing as in a letter, you will say best regards or kind regards or whatever you put in as now this is the end of the letter. Also, you need to take into consideration is the size of the message. How much data will I put into a message? How much can we send at the time? And how will these different ways that a data packet will move from one network to another, is it the same size that can be accepted on all these different networks? And that's of course what's inside these protocols, or the set of rules that we are sending or that we are using. Also, the timing itself, access method, who are allowed to send when. Can we just send whenever we have something to send, or do we take turns like we do in human communication? What are the rules? Are there some devices on our networks that are more important, that can send whenever they have something and then the rest has to wait? Or how do we, what kind of rules do we have about the access? Then there is the flow control. If something is sent too fast so that the recipient cannot really absorb it, do we need to slow down to make sure that they can handle all the information that we are sending? Is it too slow? Do we need to speed up? All these things about the flow control. Is there some kind of a congestion in our network where things stops? Do we need to redirect to another part? These things are put in the area of flow control. And also we have to have some kind of a timeout. If I haven't, and also if I want to, when I send something, I want to have a acknowledgement back that I have received the data. And if I don't hear anything, how long should I wait before I say, okay, something has gone wrong here, I need to resend it? So these timing functions need to be set in the rules as well, or in the protocol as well. So we have the content layer where we have all these communications that we want to be sent from one to another. Then we have the protocols, which is the set of rules, telling us when can we send, how can we send, how should I encapsulate it, and what will happen if something goes wrong. So we agree upon all these rules. And then we have the physical layer where the actual communication takes place. For instance, on a cable or in the air when we are talking about wireless communications. So a protocol is a set of rules describing how we should communicate between two devices on a computer network. And there are different rules, and there are different ways of communicating. When we are talking about computer networks, there are these three different types. Either it's a unicast, where I send to one. So it's a one-to-one communication. That's called a unicast. Or we can have a multicast, where one sends to many. Not all, but many. Then we have a multicast. And then in the last one is the broadcast. The broadcast is when we send to everyone on a network. So broadcast is all devices on a network. Yep. And that was it. That was the first part. Thank you.